Hello and welcome to lesson 1 on equations and inequalities. So on the screen here you can see an equivalence bar model and it's representing the calculation 7 add 3 equals 10. So these two bars, the one on the top that's made up of a 7 and a 3 and the one on the bottom which is representing 10 are equal in length. They start at the same place and they finish at the same place, and that's because they are together on the top representing the same value as what's on the bottom. So we're being asked the question, what other calculations could this bar model represent? And the first one is using the commutative law, so just switching the 3 and 7 around, so 3 add 7 is also equal to 10. Now there are two more calculations which the bar model could represent, where our calculation is a subtraction or a difference. So the difference between 10 and 3 is 7. 10 subtract 3 is 7. So if we look at our bar here, we've got 10 and then 3. And the difference between the lengths of these two bars is 7. And then the other subtraction, 10 subtract 7 is equal to 3. So the difference between the 10 bar and the 7 is what's left, which is the 3. Okay, so here we have another equivalence bar model. What I'd like you to do is to pause the video and see if you can come up with the 4 different calculations that this bar model could represent. Okay, so starting with the additions, we could have had 12 add 6 equals 18. Then using the commutative law, 6 add 12 equals 18. And then the subtractions, 18 subtract 6 equals 12, and 18 subtract 12 equals 6. Now this bar model looks a bit strange because the 6 here is much bigger in length than the 12. And it's important that we don't worry too much about these sorts of things when we're drawing out bar models, because they're just a representation of what's going on. Okay, so what I'd like you to do is pause the video and see if you can now draw out the bar models for these sums and then find the other calculations that they could represent. So in the case of the first 3, you'll be drawing out the bar models and then there will be 3 additional calculations in each case. And then the final 2, this is an extension. We haven't seen bar models for these types of sums, but I'd like you to see if you can have a go at drawing them out anyway, and see if you can find some alternative calculations. Okay, so for the first 3, your bar models should have looked something like the ones you can see on the screen. And then in each case, I've got the 3 alternative calculations, so check these with what you did. The first ones are using the commutative law, and then the second 2 are the differences which I can make from the bar model. Now, the other ones, well, this is only different because I had 3 numbers summed together on the left-hand side, so I need 3 different sections to my bar. But what it does mean is that there are a lot more different calculations which it could represent. So on the left-hand side here, I've done all of the different additions from the commutative law. And then on the right-hand side, I've done some of the differences, but I could have kept going here because there are quite a few more. And you can see I put brackets around the 3 and the 7 here to say that I need to take away both of these. If I wrote 18 subtract 3 add 7, then that would be a completely different calculation. So we need to be careful and use our brackets. Alternatively, you could write 18 subtract 3 subtract 7 equals 8. And the final one, this is what your bar model should look like, something like this. And because I've got 3 different numbers on both sides, there are a lot of different calculations that this could be representing. So what you can see on the screen are just a few of the options. Okay, so on the screen now we can see a bar model, and we've got some empty spaces underneath. So I want to remind you about something we've talked about before, partitioning. So I can partition my positive 8 into lots of different pairs of numbers. For example, I could partition into a positive 3 and a positive 5. And this would now be representing the calculation 8 is equal to positive 3 add 5. So 3 add 5 is equal to 8. Now this is an equivalence bar model, and the reason that the 2 bars are equal in length is because what I've got underneath here has to sum to what is on the top. So the length of the bars are representing the sums. Okay, so here we have another bar model, and I'm going to partition my positive 10 into positive 8 and something else. So we're being asked a question here, and that is to work out what this something else over here must be. So 10 is equal to something add 8. What does that something need to be? So that needs to be 2. Okay, what I'd like you to do for this next one is to pause the video and see if you can work out what the missing number is here on the left-hand side. Slightly more difficult this time because we've got decimals, but pause the video and see if you can find out what the missing number is by partitioning. Okay, so if I think about what I need to add to 7 to make 11, I'm going to need an additional 4. And then what I need to add to 0.3 to make 0.8 is 0.5. So altogether, I must have had in that missing space positive 4.5. Okay, so now we're moving into something a little bit more tricky. Hopefully you remember from the algebra tiles that we were using before when we were expanding brackets and so on. The red tiles are representing a negative. So we're partitioning positive 12 here into a positive number and a negative number. And that negative number is going to be negative 7. Now remember, the sum of these 2 underneath needs to make positive 12. So what I'd like you to do is to pause the video and see if you can think about what this positive number is going to be so that these 2 here sum to make 12. Okay, so this is an interesting one. If I'm going to add a negative number, then it actually means that what I must have had over here is bigger than 12. I must have started with a number bigger than 12 if I'm going to subtract 7 and get 12. So what's over here must be 7 more than 12, so that when I subtract it, I get a total length of 12. So the missing number there is 19. Now, this is a bit like I was mentioning a while ago. It seems a bit strange because the bar for 19 here is smaller than the bar for 12. So we have to kind of just run with this a little bit because it's representing a slightly interesting situation. Okay, another example. Here we're partitioning positive 6 into negative 3 and a missing number here. So what I'd like you to do now is to pause the video and see if you can work out what the missing number over here is. Okay, so just like before, if we're going to subtract 3 from this here, if we're going to add a negative 3, then we must have been starting with a number bigger than 6, and we need one that's 3 bigger than 6. so that we get a total length of 6 from these two together. And so the missing number must be 9. Okay, moving on again, we've got all red here in our bar model. So that means that we're looking at all negative numbers. And we're going to partition our negative 15 into negative 5 and something else. So I need these to sum to make negative 15. Could you pause the video and see if you can work out what the missing number is? Okay, so the missing number needs to be negative 10 because negative 10 and negative 5 will give me a total of negative 15. Okay, another example for you here, slightly different again. We've got a positive in the yellow bit and a negative in the red bit, but on the top we're making a total of negative 7. And in my yellow positive bit here, I've got a positive 5. So what am I going to need over in this section here if I'm going to have a total of negative 7? Now, this has a positive here at the moment, but we know that this is going to need to be negative. So we're adding a negative number. So we can still think of it as adding something. We're just adding a negative number. So pause the video and see if you can work out what the missing number is. Okay, so if we're going to add 5 and still end up with negative 7, we must here have a number that is even more negative than negative 7. And it's going to need to be 5 less than negative 7. And that gives me negative 12. Okay, so here is your task for today, divided up into 3 different levels, red being the most straightforward and green being the most challenging. What you need to do is draw out the bar models and then fill in the missing number in each case. So we're expecting to see the bar models drawn out, and you should be challenging yourself sufficiently. So if you're really struggling with this, it is perfectly fine for you to just do the red section, but most of you should be trying red and amber, and a good number of you should also be trying the green. So full workings in your maths books and see how you get on.